Projectiles question 2. A golfer hits a ball at an angle of 20 degrees to a level green at a velocity of 40 meters per second. Calculate for part A the time of flight of the ball. Well, first it would be useful to have a simple diagram. So here we have our 40 meters per second velocity at an angle of 20 degrees to the level green, and we can add an approximate path of the ball. The horizontal component of velocity will be 40 cos 20, as we're resolving across the angle of 20 degrees. The vertical component will be 40 sin 20, as we're resolving away from the angle of 20 degrees. We can now start to gather our data for suvat. Firstly, in the horizontal direction. The displacement we don't know. The initial horizontal velocity is what we've found here, 40 cos 20, and that comes out at 37.6 meters per second. There is no acceleration in the horizontal direction, so the final velocity will also be 37.6 meters per second. The acceleration is 0 meters per second squared, and the time we want to find. Now we can find suvat for the vertical direction, taking up as positive. The vertical displacement will be 0 as the ball returns to the ground. The initial vertical velocity is 40 sin 20, which is 13.7 meters per second. The final vertical velocity we don't know. The acceleration is due to gravity, but that is down and we're taking up as positive, so the vertical acceleration will be minus 9.81 meters per second squared. And the time is what we want to find. Incidentally, these two times will be the same. Now we need an appropriate equation of motion, and we can use s equals ut plus a half at squared in the vertical direction. Remembering that s equals 0, so we can write ut is equal to minus a half at squared, which gives us minus 2u over a is equal to t squared over t, which we can simplify to t is equal to minus 2 times u, which was 13.7 meters per second, over a, which was minus 9.81, giving a time of flight of 2.8 seconds. I can add that value to my table here, as it might come in useful later on. Part B. Find the horizontal distance the ball travels. Well, we know the time of 2.8 seconds, and we know the horizontal velocity of 37.6 meters per second, and displacement is simply given by velocity multiplied by time, which gives us 105 meters. We can add that figure to our table here. Part C. Find the vertical velocity of the ball on impact. Well, here I'm going to use v squared is equal to u squared plus 2as, and putting in the figures we know is equal to 13.7 squared plus 2 times minus 9.81 times 0. So this term disappears, and we're left with v squared is equal to 13.7 squared. But 13.7 was simply u. So that tells us that v will be equal to minus, as it's in the opposite direction, the value of u. So v is equal to minus 13.7 meters per second. We can now add that figure to our data table, which is now complete. Part B. Calculate the impact velocity of the ball. Well, we have a horizontal component of 37.6 meters per second, a vertical component of 13.7 meters per second, so this will give our resultant. But you'll notice both these figures have the same magnitude as the horizontal and vertical components of the initial velocity of the ball, and therefore the resultant will have the same magnitude. So we can say that v will be 40 meters per second, but now we need to find an angle, so we could find the angle theta to the vertical. Tan theta is equal to 37.6 over 13.7, giving theta 70 degrees. So we can say that the ball hits the ground with a velocity of 40 meters per second at an angle of 70 degrees to the vertical, or 20 degrees to the horizontal. This is the same magnitude but not the same direction as the initial velocity. For part E, we're asked to calculate the maximum height of the ball, and for this I'll find a new set of figures for Suvat, again taking up as positive, but now this is just for the upwards motion of the ball till it stops at the top of its flight. So the displacement is what we want to find. The initial velocity is still 13.7 meters per second, but now the final velocity will be 0 meters per second. The ball stops at its maximum height. A is minus 9.81 meters per second squared, and we don't need t in this case. So I can use v squared equals u squared plus 2as, and v is 0, so we can write that s is equal to minus u squared over 2a, which is, putting the numbers in here, giving a maximum height of 9.5 meters.